Hello friends, I am Manibhushan. Today I am going to discuss uh, linear regressions. So linear regressions we are using like a supervised machine learning models, and so just I have done this project. So first we try to understand what is the supervised machine learning algorithms. So if you work like a supervised learning algorithm work differently than time series model. So in a supervised machine learning model, we try to identify the relations between different variables. Like one is the target variables, another is explanatory variable. So target variable means variable that you try to forecast. Like suppose I am taking a housing price. So a housing price I want to forecast. I want try to forecast, right? Similarly, the explanatory variables. So the variable that helps you to predict the target variables. So housing price is uh, help to forecast like a size of houses, area of these houses, floor of these houses. Okay. So these are the material of this mm, product. Okay. So different things, just these are the explanatory variables. So if I go to forecast, so now the forecasting means it is important to the understand which type of explanatory variable you can or cannot use. Similarly, in this example, just I am taking a hot chocolate. It is strongly dependent on the temperature. So when a weather is cold, cells are high. When weather is warm, cells are low. And you could make a model that regroup this basics if else logic also. So if you think about like a logic could not be used for forecasting in the future. After all, if you want to forecast tomorrow sales a hot chocolate, you must know tomorrow temperature. And this is not something it would require an additional forecast of temperature. Next example is to predict hot chocolate sales not based on the weather but on the week number. So you could try to identify a relationship with the week number based on past data, then to predict the future sales, and we would input like a next week numbers into the model to obtain a forecast. So let's see just idea behind this linear regressions. We can write linear relationship between the target variable and numerous explanatory variable to predict the target variable. And one most thing we can understand like this, linear regressions is widely used not only for forecasting like any supervised model, as long as you put explanatory variable of the future input to the model. So this works perfectly. So let's see the how do we write the model. So this model we can write like this: y will equal to linear regressions like y will equal to beta naught plus beta 1 x1. The beta 1 is the coefficient. Here is the beta naught is the constant, and till beta p and xp plus e means error term. So p is an explanatory variable, this is called x, and there is a one target variable like a y. So the value of y is computed as a constant beta naught plus the values of the x variable multiples by their coefficient beta 1 and to beta 2. So beta naught and beta 1 is visually, we can see the some linear graphs in this graph. You can see if I draw like a straight line, so you can see one straight line and so many variable near about this here. So this is the most important. It means if like a increase of 1 in the x variable and increase in a y variable represent like a beta 1, and beta naught is the value for y when x is 0. So one most important thing, like we can also use beta cap OLS like a ordinary least square methods. So x transpose x, this is the matrix way, and inverse, whole inverse, and x transpose y. So this is the mathematical formula. So x as a matrix we will take here in the data sheets. So we need to estimate the coefficient like a beta on the training data sets. So this is the mathematical formula. So the linear model can fit any type of relationship that goes in one direction. So let's see, just I am taking one example like a linear model to forecast CO2 levels, and we will work with the CO2 data sets with we have already discovered this, like we have already seen in the previous videos. So this data set has the advantage of being relatively easy to work with, and it will be perfect case to show how to add target variables, seasonality and trend into supervised machine learning model. So let's see the import stats models dot API as SM, import pandas as PD, import matplotlib as PLT, just I have already discussed, and this data is already fitted in the pandas library. So data will equal to sm.datasets.co2.load underscore pandas, and CO2 I have data create a proper data set CO2 dot dropana, and ax will equal to CO2 dot plot, and now just ax dot set underscore y level, like I want to write here labels here, and plt dot show. So let's see, just I have seen this has been plotted. In the x-axis is the years of this, and y-axis represent the CO2 level. So but we need to just see your data like so your data look like this: CO2 dot head you can put, and CO2 dot tail is also you can put. So 1958, and CO2 level is this, month and years. So data, it has a like a one is the monthly and another is yearly. So in the 1958 we could see in the 3 months. Here you can see the 4 month. So we can easily realize compare this data like it. If you want to the monthly way, you can. So first creating the variable month, like a CO2 month will equal to x dot month for x in a CO2, and we have converted, and now you could see your data like a only month, don't have the like a year. So okay, so you can remove like a CO2 levels only. I have written here the month. Now the creating the variables, variable years like a CO2 years. So x dot year for x in CO2 index, so we have done here, and you could see here the years like. So let's see, just I have printed in here. So now you only have the data, dates and CO2 values. The interpreting the steps here is to do future engineering, creating additional variable based on the additional variable. And even though there is a very little information in this data sets, and there is a lot of variable that you can create from it. So exactly, just if you write here like if you start like a seasonal variable from the date variable, so we can see from the plot there is a strong seasonal pattern going on, and we could try to capture this by adding a monthly seasonality to the model. So for this it is necessary to create a variable month in your data sets. And another, just I have written here like a month. Yeah, so then you could see the variable for a monthly seasonality. So let's see the whether you can create a variable that captures the long-term upward trend. And we will see in this solutions yeah, you can say that to this problem to add a variable year by extracting the year from the date variable. So there is a yearly increase in the data. The trend effect could be captured by this variable. Next, the creating the variables like a year, x dot year for x in a CO2 index. Okay, so this value like a CO2 years, and another just I have taken fitting the linear regressions with the two variables. So I am taking a x as a one variable, capital X, and CO2 year and month, and y is a like a CO2 levels. Okay, so dependent and independent variable we could see, and from the sklearn model underscore selections import a trend test. So we are creating a like a training and testing of this data. So x train, x test, y train, y test. So x train test splits and capital X comma y test and size. I am taking the only the 20% of the data for the testing purpose. Random step 1 2 3 4 5 comma shuffle false. And from sklearn again just linear underscore model import linear regressions. From sklearn matrices import r square scores and my underscore lm linear regressions. And now I am going to the fit here, my underscore lm dot fit x capital X will equal to x train and a small y will equal to y train. And training like a forecast, my lm dot predict x and x underscore train, and testing forecast like my lm predict x underscore test. And then we have gotten a result like a r square. So let's see, try here. Just I have gotten 96% and 34%. So this is our result So one is the like a testing forecast and another is like a y test. So steps into the test like the, so in this data like a R square model I have gotten like a 96%, which is a great, and the test R square is 0.36, which is a relatively bad. So we can see fit on the test sets and see that there is some improvement to be made. So next thing, just you can see here like the adding the some lags variable into this data, and CO2 like a linear 1 CO2 and shifted 1 CO2. So these are the lags: CO2, linear 3, linear 4, linear 5. So just I have uh, add to the modules is the auto regressive components, and this will be done in the future engineering. And now we will see, we always in the like a supervised model we need to the extract some informations, any informations as an exploratory variable. So in this example we will see here how to use the shift methods to create lagged variable. So we are creating a lag variable in this method. So let's see, the we have taken like a 1 2 3 4 5 lag variable easily I am using. So adding a lagging variable create a not available in the data sheets, and this is a broader effects, and it is a not a problem. It simply delete any missing data with the listings. Okay, so then after that we will see here like your data has been seen look like here. So this one is the lag variable, this one, this one, this one. Okay, so you could see now 2220 rows and 8 columns in this data. So drop a missing value like a drop on, just I written there, and then after that CO2 drop on. So as a final steps, let's fit the evaluate the model with the monthly seasonality and the yearly trend and the 5 auto-regressive lag variables. So you must not here the since we added the lag values into the trend sets, it would be impossible to do this for multiple steps forward. You calculate the first feature value using the data for today, and you calculate the second feature value by using the data of tomorrow. So therefore the error that you evaluate here should be interpreted as one step forecasting error, where the previous code block did a multi-steps forecastings. So create x and y like here. So CO2 year month, CO2 1 2 3 4 5 all are the lag variable, and now we could see here the x y as a variable. Again we will apply the same algorithms like a x train and y x test, y train y test, and train test split x y test size like a 20, random underscore state 1 2 3 4 5 dot shuffle false, fit the model my lm linear regressions, my lm dot fit x will equal to x train y y underscore train, train forecast my underscore lm dot predict x underscore train, test underscore forecast my underscore lm dot predict x underscore test, train underscore r square will equal to r square underscore x y underscore train forecast, test underscore r square underscores and y test and test underscore forecast and print train underscore r square test underscore r square. Now I'm going to the plot here. So you could see here your plot. What happened? 99%. So your accuracy rate has been increased and your test level is also increased. This is so r square trained scores of this model is 99. So the test r square is like a 99. This is the great performance in this model. So r square train scores is like a 99 and r square test score is also 99. So it's a great performance. So we can see in the plot the predictions like actual value almost perfect. So what we have seen this is the predictive performance plot of the full model. So we have seen how to add a time series trend into a supervised model, and you have used a linear model to obtain this result. So this is our motives and we have learned. So these are the some important point you keep in your mind, like a linear model is the simplest supervised machine learning model, and another linear model find the best linear combinations of external variable to forecast the future, and linear model cannot easily adapt to non-linear situations. Feature engineering is the task to creating the best possible variable in your data sets. Otherwise, in order to obtain the explanatory variables that can help you model to obtain the best performance, seasonality can be fitted by a supervised model when you introduce a seasonal variable. Trend can be fitted by a supervised model when you introduce a trend variable, and auto regressions can be fitted by a supervised model. You can add lagged, we have taken 5 lags actually, lagged versions of target variable into explanatory variables. So I hope this video will be help everyone, and thank you very much. I will discuss in the next class. I will try like the so many models, decision tree models, XGBoost models. Okay, so I will try to discuss KNN models. Okay, and so it's a better random forest models is all. We will try to discuss one by one, don't worry, but just gradient boostings with like a XGBoost and light GBMs. And so I try to cover all these models, and let's see just because whenever if you go in the advanced machines and deep learning models, so need to understand like a neural works like a Keras, PCA. Okay, these are the very important, and then after that we need to understand RNN, like using the simple RNN and GRI, recurrent neural network like this. Okay, and GRU as a gated recurrent unit. And another one more thing like LSTM is the very important, long short-term memory. Okay, so let's read and try to understand, do the better, and we create something new in our life. Thank you very much.